Inspire can optimize a design, especially for additive manufacturing, while taking care of material-specific overhang constraints. In this example of two bearing housings, we will optimize the red design space. Before, we check the deflections and stresses of the initial design. The stresses seems to be high in the rod, but by using the filter, we can clearly detect low stresses in the bearing houses itself. An optimization with the objective of maximizing the stiffness while using a fixed material goal seems to be appropriate. We will set up the optimization 3 times to understand design differences in overhang constraints as well as performance differences. At first we use no overhang constraint just to have a best performer we can compare with. Now we apply the overhang constraint to our design space. Depending on the process and material, we set the critical overhang angle. The resulting optimization is forced to create a design with the design space manufacturable without any support structure. By activating the lenient method for the overhang constraint, we enable a penalty factor for overhang areas. Inspire is creating a material distribution which violates the overhang constraint, but only if structural highly efficient areas are detected. The first approach is created without a manufacturing constraint, probably just manufacturable with a support structure. The second approach can be manufactured with a minimum amount of support structures, but the mechanical performance can be worse. The third approach shows a design with a reasonable amount of support structures necessary. To understand the performance differences, we analyze different approaches and compare them regarding stiffness and strength. We can do this run by run or by creating a table. Sorting this table by maximum deflection and comparing the strength, we can easily take decisions based on our particular design goal. Minimum weight, maximal stiffness, or the best manufacturability, or maybe the most elegant combination in between.